Guys, girls, it's time for another motherboard repair video. This one's retro gaming motherboard, really. It's quite an unusual motherboard. Four PCI slots, one PCIe slot, and one AGP slot. What makes these boards interesting is that they can be used for retro gaming rigs with Windows XP and Windows 98. So Windows 98 will support AGP graphics cards, and it's quite possible with one of these to make a dual boot system. That basically maybe two hard drives, two SSDs, one with Windows 98, one with XP. You can also then put two graphics cards in here, so you can have an AGP and a PCIe faster card, and you can set this up so that which operating system you boot into, you get the graphics card you want automatically. So that's nice. PCIe. You could also actually, I believe, even put a PCIe graphics card in this. Sorry, a PCI graphics card in this as well. So that's what it has. But the other thing that makes this really interesting is that it's a socket 775, and this will take like Core 2 Duos, Core 2 Quads. I think it's also compatible with like Core 2 Extreme and some of the Xeon processors. So you can basically build a machine like this, with like a Core 2 Duo, Core 2 Quad, with AGP running Windows 98 that would absolutely, would have blown out of the water any rig that was available at that time. So you can take old games, Windows 98, and completely max them out. But beyond your wildest dreams of what you could have done around sort of like 1998, 1999. So that's the good thing with it. The bad thing with this board is that we have a lot of faulty capacitors that have dried up, blown, bulged, and I'll just zoom the camera and you can actually have a look to see what we have there. So as you can see, there's a lot of capacitors here that are basically knackered. Okay, first one is here, and I don't know if you can see, maybe I've got more from a side view, that effectively the top of this capacitor is bulged outwards. Yeah, this is a good one in comparison. So it's bulged. Also this kind of dark traces of some material here. This is effectively the liquid coming out of the capacitor. Again, we can see two more of them here, which they have like a convex dome, yeah, whereas this one is flat, almost concave. So again, this is a good capacitor. These are two bad ones. There's actually one I've already removed from here on a previous video. I think I've just showed how to remove a capacitor. Again, there's another one there that's done the same thing. The other thing you'll probably notice, motherboard, it's very dirty. Yeah, it's really grubby. So what we need to do with this initially is to replace these faulty capacitors and to clean this up. This wants to go in the sink with water and give it a good scrub, because it's possible that all this dirt on here, I mean, I doubt it's conductive, but you never know, and you don't want to cause any sort of instability really. So we have visibly 1, 2, 3, 4, and I'd say there was a fifth one which I removed from here, so that's 5. These circuits are actually buck regulators. They look a bit different from the ones you've seen on modern boards, but they're buck regulators. So on each one we have an input capacitor, yeah, output capacitor. This is your buck regulator coil, and here you'll find your two MOSFETs, upper and lower side MOSFETs, yeah. And the same here, we could use the input capacitor, two output capacitors, the upper and lower side MOSFETs, and the coil again. And the same down here. And this one appears to have 4 phases, 1, 2, 3, 4, yeah. And if we look at these capacitors, you'll see that the ones that are bulged are all on the low voltage side. So we've got 6.3 volts, 1500 microfarads, yeah, and that one's gone. Again, this one here, 6.3 volts, 1500 microfarads, yeah, that one behind's the same, and these are the same, yeah. the other capacitors you see around here will be on the high voltage side. So all these 6.3s will be on V core, yeah, the low voltage side, the supply to the processor. All the other ones, I think, and I'll just check them, are actually the high voltage. So you'll have 12 volts coming in here, yeah. So I think all these good looking ones are on the 12 volts. Let's have a quick look, see what we can see. This one's easy to look at. Yeah, okay. If we get a bit of focus, right, let me get the torch so we can see it. Let's get the torch on there. 1000 microfarads, yeah, 16 volt. Okay, so that's on the 12 volt side. And I'm assuming, cleaning the dust off this one, yeah. Once again, let's get a bit more dust off it. 1000 at 16, I think we'll find that one is, yeah, just in there, 16. And this next one back here again is 1000 off 16. You can just see the markings on it. And the two behind there will be the same. So what we have is the 12 volt capacitors are good and the low voltage ones are no good. And that's not surprising because these low voltage ones are on the low voltage side of this coil. These are getting the high frequency pulsing very rapidly. The 16 volt ones are on your 12 volt rail, and that's already got smoothing in the you know, your ATX power supply. So they're not doing anywhere as much work as these are, and that's why these have failed. So what we're going to replace them with? Well, I haven't actually got any of the same capacitors, but what I do have, let's move over, I'll just pause the camera again. Now what I do have is this motherboard, H57H. This was some sort of i3 or something like that. This is a scrap motherboard, it's a different socket type. This is the one, if you watch the video, we took the PCIe connector off, I took this Super I/O off it, and this is a scrap board that actually had a faulty north bridge that was nothing could be done with, it wasn't worth doing anything with. And this one has you know, the same sort of thing, your V core, your high voltage capacitors all around here, and these are all your low voltage capacitors. So let's have a zoom in and see what we actually have there. Yeah, okay, actually I just checked as well while I was zooming the camera. This is a socket 1156 motherboard. So this would have supported the first generation of i3, i5 and i7 processors. So it's a good few years newer than that other board we have. We can see on here similar sort of setup. So you've got your input capacitors that are rated at 16 volts. So we know these must be on the 12 volt supply from here. Slightly more modern looking controllers. That's the actual controller itself, a phase controller. These are your MOSFETs and pairs for each phase, yeah. So this is the pulse width modulation controller, basically the VRM controller. And again, you can see there's down here, so it looks like we have four or five phases here. And on the output capacitor side, we have a lot of these. So these are 820 microfarad, 2.5 volts, and we've got a lot of them. And these are like polymer capacitors, I believe. They're a lot newer than the old type electrolytics we had on that other board. And these are much better capacitors. But the question is, are they any use to us for this job? And actually the answer is, surprisingly, maybe, yes. The other ones were rated at 1500 microfarad. These are only rated at 820, so about half the rating, yeah? The others are rated at 6.5 volt or 6.3 volt. These are rated at 2.5 volt. Now, there's two reasons why I say we can use the capacitors we can salvage from this board to repair the other one. The first one is the voltage, yeah? What voltage are we ever going to see on this voltage rail? I know the other ones were rated at 6.3, but we can kind of work this out because we know this is a Core 2 Duo or a Core 2 Quad going on the other board, socket 775. So if we Google to see what is the maximum V core for that type of process, we'll know what's the maximum supply rail we'll ever see on VCore on that board. And if it's less than the 2.5 that these are rated at, then we can confidently use them, yeah? So let's have a quick look and see what voltage rail would be required for that type of processor. Let's go over to the desktop. Okay, so what we were interested in is basically, that was the other motherboard, by the way. I was just looking up H57M because I was just interested to see what it supported, and this is how I know it was the socket, the 1156, and you can see it was early version i7s, i5s. Let's have a look to see what voltage we actually got on our other board. So we'll go for Core 2 Duo, yeah, maximum VCore. Let's put VCore. Yeah, let's spell it right. Now let's have a look to see safe voltage for Core 2 processors. That's a good one. Let's have a look. Yeah, does anybody have an input on what's the safe voltage? And he's saying he's got 4.625. Oh, I take it you mean 1.4625. Okay, so 1.5 this guy's using. They're talking about speeds. Yeah, he's got 1.46. Somebody's saying that anything less than 1.5. Read the box. It says maximum 1.35. So I think we can assume that our Core 2 Duo or Core 2 Quad, as I'm sure would have the same VCore, which we're going to stick in this Super Retro Gaming. Correct voltage for Core 2 Quad. Let's have a quick look at that. 1.7 is too much. Okay. 1.7 is too much. So we know that we're going to get maybe something like 1.5, let's say 1.3 to 1.6 if we're going to actually overclock this thing, yeah? Okay, let's go back over to the camera again. Okay, so we know from that information that on our retro gaming rig, we can replace those 6.3 or 6.5 volt capacitors with these 2.5, because it's never, even if we overclock it, the VCore is never going to be more than 1.6, and that's enough headroom, yeah? So the voltage we can get away with. Now the other thing is the capacitance, 820 microfarads, yeah? That's half of the other one. Now the reason I'm confident we can also get away with that, let's have a look at the board again. Okay, if we look at this one, this is where I've already unsoldered one, as I've told you about. We have here a number of like spare spaces for more capacitors, yeah, here and here, and they're unpopulated, there's no capacitors in them, but there's space for more capacitors. So what I can do is effectively fit more capacitors on each phase, yeah. I might get, I'm assuming there's 4 phases, and I've not tracked these out, but I'm guessing I can get 4 more capacitors in, yeah? By taking out the 4 bad ones, 5 bad ones. But that tells me, and bear in mind that all the phases are connected together on VCore, so I'm expecting that all these capacitors, including these spare unpopulated spaces, are all on VCore. And if they are, then that means we can put more capacitors in. So we can probably roughly double the amount of capacitors, yeah? And that will give us the extra. So if they're 820 each, and we can get probably twice as many in, we got, if you know, like 8 of those is equivalent to 4 of 1600, or 8 of 800, yeah? So we can get away with the capacitance that way as well. So I'm confident we can do this. So the first thing we're going to have to do is to take out all these faulty capacitors and clear the holes, yeah? Then we will use a test meter and make sure, obviously all the grounds will all be connected together, make sure all the positives of these are also connecting to the positives of these. And if that's the case, then we know we can put more capacitors in. Once we've done that, this is going to go in the sink with a bit of soap and water, get a good clean, and then it's going to be dried out thoroughly. And then we're going to effectively, you know, fit all the new capacitors. I say new, the ones we salvaged off the other board. So, without any more messing about, no more ado, as they say, let's get salvaging, okay? Right, we'll go over to the other motherboard first. Well, actually, no. Let's start with the board we want to repair. The reason being, I can remove these capacitors, get this thing in the sink and wash it. And then this can start drying out while we're working on the other one, yeah? So let's get all these duff capacitors off here first. This is not difficult to do. You need a decent soldering iron. This is my T12 KSGAR. You try pronounce it, I can't. This is a BC3 tip on here, yeah, and I've got it set at 320 degrees. And basically I'm going to just remove these capacitors. The way I'm going to do it, so if we can keep this in focus while I'm actually doing this, I might have to actually adjust the camera slightly. One moment. Yeah, that's got a pretty nice focus on that while I lift it up. So the way I do this basically is I heat both pins at the same time and just pull the capacitor out. So what we'll do is first is we'll add a bit of leaded solder. It's this one, yeah. First, let's just get a bit of leaded solder in here onto the job. Okay, I've actually managed to make a solder bridge. That's what I wanted. I've actually got, can you see, it's a solder bridge between the two pins, yeah? So now I can just get in with the soldering iron, heat both pins at the same time, give it a few seconds to go through, there, out it came, yeah? Let's do another one. So next one's here and here. Okay, again, this one. Try to get a solder bridge between the two pins, yeah, a blob. Okay, I've got a blob between the two again. So once again, I can just get hold of the capacitor with my fingers, hit the blob, and it should just come out. There. The next one's here. Again, that's the blob. Hit the blob. A few seconds. Out it comes. I'll just clean that blob of solder off there because it was a big blob running down the board now. Let's just deal with that. So that's 3 out, yeah, already. Already 3 out. So just so we can just pick up this bit of solder. There we go. Okay, that's 3, and we have 2 more. Oh, it's not focusing so well down here. We have 2 more. One here, yeah. So is that one? It is one. That one actually looks okay. It's not bulging, but if all the others have failed, change it, yeah? Even though that one hasn't visibly failed like the other ones have, you should change it. So these 2 pins here, again, let's try to bridge the 2 pins with a good gob of solder on there, yeah? Okay, done it. And the other one is just here, yeah? So once again, let's try and bridge that with a gob of solder, okay? Done. Right, so this one again, I'm just going to hold it with my fingers. Yeah. A bit of heat into it, melt the blob, wait a few seconds. I'm not putting any pressure on this. Just letting the solder heat do the work, yeah. Out it comes. Again over to the other one here. Yeah. Heat her up, let the solder do the work. Out it comes. So that's how to take capacitors off a motherboard easily, yeah, with no chance of damaging the board, no lifting any pads, ones on the floor. Okay, that's how to do that. Okay, let's now try to clean up the holes, yeah, so we can see where we've been working. I'll zoom in on this now because we've got it nice and flat. Okay, so these are the first 2 that I removed. One from here, one from here. I've also managed to get a blob of solder onto this pad here, which doesn't do anything just apart from helping the current to flow around this. So we won't worry too much about that bit on there. I'll clean this off, but it's not anything to concern about. Yeah. So the first way we'll try and clean these out is going to be with just solder braid and a bit of flux, yeah, and the soldering iron. The third one I think is here as well by the looks of it. I'll just check out the other side of the board. Yeah, there's one down here as well. 1, 2, 3 and 4 are very close together here. Okay, I can see number 4 as well, so number 4's there, yeah? So you can see now. 1, 2, 3, 4. Okay. So we'll try this, see whether or not we can actually do this with solder braid or not. Maybe we can, maybe we can't. I'll get a bit of flux on the braid itself because this always helps a lot with this. And let's see if we can actually clear these out with solder. Give it a few seconds. Yeah, I thought that might happen. It looks like we've got one clear and one of them still got solder, so probably the one on the ground plane, which is the harder one to get, yeah? Let's try again. Okay, I'll just see if I can see through the holes one moment. Yeah. What I have, but that one's clear and this one isn't. We can try once again. We'll put some leaded solder on this because the leaded solder has a lower melting point, and this might help it to actually desolder, yeah? So again, a bit of leaded solder, bit of flux on the braid, bit of flux on the braid there. Let's go once again, see if we can get it, yeah? I think that's through. I've got little, some little needles which help with this. So that one's going through, yeah. This one here isn't going through, so we'll do the same with this one. A bit of solder, leaded solder into the thick pin. Again, a bit of solder braid, a bit of flux on the braid, and we'll try and get enough heat in to do this one. And it's not going to come. You can often do this with a needle, yeah? So what we can try is we can just try warm the pad, put the needle in the indentation basically, and see if this will actually go through. No, that's not going to go easily. Another method, we'll try this one, is to use hot air with a needle. So again, we get the needle into the hole, we get hot air, I'll just gently warm. I'm on 450 on the hot air with maximum airflow. Let's see if this will actually go through. Doesn't want to give it up easily, does it? But now we've got it hot, we may do it. Yeah. Little touch then, yeah? Little touch of the soldering iron, and it went through. So that's how to do it the hard way, yeah? That's how to do it the hard way. But you can do it. I've shown you can do it, yeah? Now let's do it the easy way. Let's do it the easy way. Get yourself one of these. They're about €60 or 7 something. You know, they vary a little bit. There's a few different makes. Mine doesn't even have a brand on. I know Pros Kit make one. There's a ZD915 or 7 that is the same sort of thing. Yeah, get one of these. This makes life a lot easier. I'll show you. Just pulling air through. Go to the next one, which is here. Count to like 5. Pull the trigger. Hole clean. Yeah. Next side of it. Bit of leaded solder. Maybe count a few more seconds because this one's on the ground plane. It's clean, yeah? That's the way to do this. Once you've done the one the hard way and you've made some money out of it, buy yourself one of these, yeah? Have I convinced you? Have I convinced you now? Have I convinced you this is the way to do this? That's 3 done. 4th one is here, I believe. That one didn't suck through. Let's have a quick look if I'm in the right place actually. Yeah, I'm in the right place. Okay. That one didn't do it. Let's go again at it. Get some leaded solder in, yeah? Get some leaded solder into the job, yeah? Let's get the... I'll just make sure this is clear. Sometimes when you've unsoldered some of these, the thing clogs up. A needle. Yeah, it's fine. That's going all the way in, yeah? That's clean. Let's have another go at it. Count to like 5, 6, 7, 8, 9, go. That one's clear. Again, count like, 6, 7, 8, 9. That one's clear, yeah? You don't need to waggle it around when you're doing that because you don't want to take the pad off, yeah? So don't get scrubbing at it while you're trying to get heat into it. Just hold it still, yeah? Hold it still. So we've got one here and one here, and that's all of them. Once again, a bit of leaded solder. This helps to reduce the melting point a little bit and helps to conduct the heat in. That one's clear. Okay, 8, 9, 10. Yeah. Clear. Oh, maybe not that one. You can sometimes get a troublesome one. Even with this, it won't do us. But if that's the case, I'll show you how to get around that. It's not. It's taken this one. This is clean. This one here has been the problem. So once again, let's just make sure this isn't actually clogged up. No, it's not. Let's get a bit of solder on again on this one. So a bit of solder, leaded into the hole, solder into the hole. Yeah. Let's come at it again. And give it like 5, 6, 7, 8, 9, go. That one's clear. Somebody at the door, one moment. And that one still isn't clear. I'll be back in a minute. Okay guys, little interruption there, just somebody at the door. Need some laptop batteries. Actually, so we have one troublesome one here, which I'm actually quite glad we've got that, because I can now show you that sometimes this fails, and when this fails, there's another technique. So once again, we'll come in and we'll put some solder on that one, yeah? Once again, the desoldering gun, we'll make sure it's clean, not clogged up. It doesn't clog up very often, to be honest with you. When it does clog up, it can be a right pain. So there's a few things if you've got one of these. Always suck air through it before you switch it off, and clear it before you switch it off. That's the main one. And don't try to desolder with too much flux, because that sticks the thing up. Okay, so troublesome one, yeah? This is where we get brutal. Hot air and desolder gun together, yeah? . I've never seen this fail. Let's watch first time on camera it fails. Nah, ha ha ha. Ha ha. I have never seen this plus that quick 861 fail ever on anything. Yeah. Okay, so that's how to do that job. This will now go into the wash, and we'll have a look when we finished when it's dried. Yeah, I'll now take the capacitors off the other board. I need to clear the holes in the ones that are like spare spaces, but we'll see if they're connected to where we want first to be sure. So yeah, this is going to the sink now, soap and water. I won't continue the recording removing the salvage capacitor because it's the same method as this anyway. Plus we don't have to clean the holes out, so it's even easier. So I'll see you guys when this board is clean and dry and ready to continue. Hey guys, it's tomorrow. It's tomorrow now. Told you that would take me a bit longer than he would be waiting to watch. So yeah, this is the motherboard, which is now being in the sink with some soap and water basically, and I'm sure you can agree it's looking much cleaner now, much more respectable. You can see obviously I've removed the CMOS battery while I was washing the board, of course. So yeah, that's much better. I mean, it's not as clean as maybe like an ultrasonic bath would have got it. Maybe there's a little bit of dust still down in here, but it's good. I'm happy enough. So what we're just going to do now is have a look to see if these capacitors here and here, the ones where there was nothing there, are on the same rail as the other 5. So yeah, let's have a look at that. Let's just get the test meter so you can see it, and then we'll do that. So I think we'll just do it this way. It's as easy, isn't it? It's as easy. Okay, so we're on resistance mode. Yeah. The white end of the capacitors. This is the ground end. I'm sure we'll just check. Oh, the black end is not black. Like the blank end is ground. Yeah. So that's ground on each of them. I actually expected it to be the other way around, to be quite honest. These are the ones where there was no capacitor. There was none there. There was none there. There was none here. So these are all connecting to ground. You'd expect that. Now what we're more interested in is whether the other end, which will be the positive, is actually connected as well. Yeah. So obviously these are all on the same voltage rail as you expected, V-core, and we have these spare spaces here, 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 here. Yeah, there's 4 of them. So where there was originally 5 capacitors, we can now get 9. 1, 2, 3, 4. Yeah, there were 6 originally. Sorry, there were 6 originally, and I can get 4 more. So that's not like, if I'm using half the value, it's not quite doubling, but I think it's close enough. I think I'll add it up in a minute. 8 times 820 on each and see how many we actually had. There's a 1, 2, 3, 4, 5, 6, 7, 8. Oh, it's 10. That's easy, isn't it? So it was like 8,200. And before we had 1,500, we had 6 of them, which is 9,000. So yeah, that's close enough in microfarads for my reckoning anyway. Okay, so what we're going to do now is clear out the holes in those on the board, yeah, and we can solder the capacitors. But before we do that, let's have a quick look at the original capacitors, and let's have a quick look at the new ones, because obviously these are salvaged now from another board, yeah. So I have here these are some of the original ones, 5. The 6th one I actually removed on another video where I wanted a faulty capacitor on the capacitors video. That's why that was all missing. This one looks to be in good condition, yeah. The rest of them are bulged, yeah, you can see that, I'm sure. So let's have a look at this one that looks to be in good condition and see what capacitance reads on the capacitance meter and the ESR on the ESR meter, and then I've got a few, a couple of the bad ones, and then what we need to do then is check all the ones we salvage from the other board to make sure they're good. So I'm on 2000 microfarad range, yeah. Black to the negative. So this is the one that looked okay. And it reads okay. I mean, yeah, 1586, yeah, 1500. That reads okay, that one. So one or two of these bad ones that got the bulged out lids on them, yeah. Let's have a look at this one. That's reading basically 0. Less than 1, shall we say, yeah. Let's have a look at another one. Make sure I don't get my finger on it as well. Not to harm my finger, it's just that I want to get a proper reading. That was no good, that was 0 or thereabouts. So we've got another one. 0. Yeah, so they're basically reading 0. Here's the last one. Sure, this will be the same. So effectively, we had like 1 capacitor working out of those 5. I know the 6th one was faulty because I did another video with it. So that obviously wasn't very good. Let's look at the ESR. So we finished with the capacitance meter. Let's have a look on the ESR meter. So this basically sends a 100 kilohertz signal through the capacitor and sees how well the capacitor actually passes AC. So again, this is the one that looks okay, yeah. I'll just 0 the lead, so I need to connect these two together, make sure I've got a good contact, it's a little bit iffy on this, and press the 0 button. Okay, the range is on 0 to 1 ohms, yeah, so this will be down to like 1,000th of an ohm. So let's have a look at this one, observing the polarity again, black lead to the negative connection. And that's quite low, 0.05, 0.06. Let's have a look at one of the bad ones. I'm expecting this to be high, certainly more than 1. Yeah, that's just high. There's no nothing there. I could go and check on the 10 ohm or 100 ohm range, but there's no point because they're no good. Yeah. Let's have a look at some of the ones that we salvaged. Yeah. So these are the 820 mic. I'm assuming the stripes the negative, and I'll have to just have a quick look at the on the old motherboard side they were connected to be sure, but I'm sure that normally the stripe is negative, the same as these, the stripe is negative, yeah. I can soon check that by just having a look at how they were on the old motherboard where we salvaged them from. I have the video of it, I know which way they were round, and I can soon find out which end was ground. So let's go stripe as negative, yeah. Measure the ESR of one of these. It's as good as the one that we that's possibly good on out of the others. So that's quite low. Go for this one. Yeah, let's just down to there. See, that's a bit lower. Just struggling to get a very good connection there, but we'll try. Yeah. You can see what I'm doing. I'm off the screen. Yeah. So those two are good. So what I'll do is I'll go through all those and find 10 good ones, and we can put them onto the board. I just want to show you with that other motherboard. So obviously I've had it in this sink, yeah. So what I did is I have this. You can see it's just a fan. It's connected to a 12 volt power pack here, 12 volts, with a cow in. This is off an old scrap computer or something. I took the motherboard off because it was worth money, but the computer wasn't. This is what I use for drying. So basically, I wash the I wash the motherboard in the sink. It's actually hand wash rather than soap that I use. And soft paintbrush, as you just saw me with earlier. Soft paintbrush, yeah, just rub over everything. say take the CMOS battery off first, that's an important one. And then I basically get the board, what I do is actually a bit brutal, you might think. I get the board, you can see it here, yeah? And I very vigorously shake it. Like so, yeah? Turn it around, and again, and that like, kind of throws off a lot the spare water. Again, I turn it upside down, and the same thing both ways, and also sideways, yeah? So I shake that as hard as I can to remove a lot of the spare water. I then literally just sort of like balance it up on something and put the fan in front of it and give it like 15 or 20 minutes, and I turn it round, and I do this for a few hours, yeah? I try to get it above onto here. So I give it a few hours of that, just moving this around every 20 minutes. And then I just leave it overnight. Now, my workshop is quite warm. I mean, I've got, let me just show you. I've got the air conditioning on at the moment because it was really warm when I came in this morning. But even now with the aircon on, you can see and I've had the aircon on for about 40 minutes since I came in this morning. And you can see the ambient temperature is like a good 26 degrees, yeah? The motherboard's a little bit warmer, 27, yeah? So, yeah, you can see about 27. So, in my workshop, I don't need to use a heater to dry the boards. Just having the fan blowing air, it's effectively blowing air at that temperature, yeah? And then I leave it standing overnight, propped up on one edge, and that's good enough. Where you are, your weather might be a bit shit, to be honest. If you live somewhere with shit weather, then you might have to use a hair dryer or a fan heater. Don't get too close, don't get too hot, but you might have to apply some warm air, yeah, over a period of time to dry it. You want to dry this out quite quickly. You don't want to get stupidly hot, but you don't want it to stay wet for a long time, where the point is the water can start to cause any corrosion. So you want to have it dried, pretty much dried in an hour, really. So obviously, depending on your location, let me know, what you have to do in your workshop. But yeah, just keep that in mind. Okay, so I'll get the desoldering and clean these out, and I'll just solder the replacements. I don't think I need to really do it on video. I might just show you soldering one, so you've seen the desoldering earlier in this video. So I'll be back in well, I don't know. Won't take me long to this, 20 minutes. Let's see. Okay, so I've cleared out all the holes. I haven't fitted the capacitors just yet. I checked back on the earlier video, or earlier off of this video, to see how these capacitors were oriented on the other board. And as I was correctly assuming, the stripe is a negative end, because on the other one it actually says positive on one side. The interesting thing is that on this board, the stripe is the positive end, and the non-stripe is a negative. You can see that quite clearly by just taking the multimeter and just checking. I did this before, but I'll just show you again. So from the stripe end, if I go to ground, there's nothing, yeah? That's not a good ground. Let's find a good ground that you can actually see. Top of here, yeah? So you can see that this end is ground and this end isn't. This is positive, yeah? The interesting thing is, on the other motherboard, it's the opposite way round, yeah? The stripe end is a negative. So it's a good job I checked that, and do check this. Make sure you're putting the capacitors in the right way round. Don't just rely on the markings on the board, yeah? Get yourself and have a look to see that that is right. Otherwise, you're going to regret that, I'll tell you, if you didn't do that, okay? Other quick thing I just want to show you is I've just put one of the capacitors in. I've tested all these capacitors on the capacitance meter. I didn't do this before, I just showed you on the ESR meter. What I have, let me just get the cables. I'm on the 2000 microfarad ohm. So the stripe is negative, This end is positive. And you can see they're all reading about 960. Yeah, I went through 10 and they read between 930 and 960. I found one that read 870, so I discarded that one. Maybe, you know, I had to get a lot of heat into some of these to unsolder them. So I've got 10 that all read the same, and they're also reading quite a bit more than the 820. So on our calculation, we can now add another almost 1,000 microfarads, which brings it into the sort of 9 that the other one was giving us. The other quick thing I just want to show you is this. So this is the vacuum desoldering station that I use, yeah? You can see it's a bit better now. It's set at 385 degrees centigrade. As you saw in the other video, I had to use hot air as well on some of the holes to remove this, but that's how it's actually set, yeah. That's mine. I'm not sure what make this is. It doesn't have a brand name on. They come under quite a few different varieties, but you can generally tell because the hand tool is the same, yeah. They're 90 watts. I've seen some of them that say they're like 110 or 120 watts. Now when you look at the picture of the hand tool, it's 90. So I think they're all actually 90. So that is the desoldering tool. So now I'm going to go ahead and solder all these capacitors, and now let's see what happens. Okay, I've got 4 of them in now. They're going quite easily. I'm finding on some of them there's like I'm having to just get a soldering iron against the legs. There's like little remnants of solder that makes it very difficult getting to the hole. I'm having to splay the legs out very slightly as well to get them to fit. So I'm kind of you know, like this with a pair of needle nose pliers, just spreading them out slightly, and I'm just taking a soldering iron with no solder on, clean tip, yeah, and just touching against the legs, and it's like removing bits of residual solder, and then I find they fit in quite easily. The other thing I'm doing is I have the capacitance meter here. I have 4 fitted now, and you can see if I just measure to ground from the positive end, I'm reading like 3.6, 3.7. So you know that's right. It's about roughly 900 for each one. I said I'm reading a bit over 900. So as I fit each one, I'm going along and just checking the total capacitance. That's telling me that each one is soldered correctly, yeah, and that each one is fine, you know, after being heated again. So I'll carry on, and I'll be back with you when I've done the rest of them. Okay, so that's all of the capacitors replaced now. Taking care to make sure the polarity is correct on each one. 10 of them. I've been checking the capacitance on as I do each one to make sure everyone's soldered properly. It's a good thing I did that, because on the first attempt one of them didn't. I had to add a bit of flux, and then it did. So we now go, they're all replaced, but if we now go across the whole lot with the right polarity, it takes a while to build up the reading, but it gets up to 9. Okay, near to 8, fair enough. It'll be the same on all of them because they're all soldered in, yeah. Okay, so we know that's good, it's around 8,000, which is fine. So what we're going to do now with this basically is to stick a CPU in, a bit of RAM, connect the power supply, and let's see if we can get to the BIOS screen. Oh, I missed a step, guys. Clean all the flux off, yeah, before we test it. So I've cleaned all the flux off the board, and I noticed actually then that the last one I'd soldered, the very last joint, wasn't well soldered. It must have been intermittent. You know, I said, well, I had it reading 9 before. So now we can just check. I've soldered that properly, added a bit of flux, redid it. So if we go across one of the capacitors now, yeah, there you go. That's near to 9. 9 is what we expected to read, yeah. So that's very close. Okay. So I think we can call that a job well done. Let's put it together and see if it boots up. Okay, so we're ready to go with this. I've put a Core 2 Duo in here. It's only a 1.86 gigahertz, just one I've lying around. It's for testing. I'm using this power supply because this only has a 20-way ATX connector and not the 24-way, which is on the one I use with test rig. So this is a power supply I keep around. I've just wrote good on it, and I use this for these sort of things. So it still has a 4-way the EATX 12 volt. It has the 20 pin in there. So we're good to go really. I've put the post analyzer in. I always do this just to see what's happening. Switch, speaker, yeah. This is a known good PCIe card. It's nothing amazing. It's a HD 2400 Pro, 256 meg. But it's a great little card for testing. It doesn't have a cooling fan on, so it's silent. And it appears to be compatible with pretty much anything. So we'll have that in there. Get the monitor. Yeah, I've put 2 gig of DDR2 in here, yeah. Just the cooling fan was just balanced on top, it's not bolted down, but that's good enough for testing. So that's the test rig that we're going to use. Well, that's how we're going to test this board. So, power on. I have a slightly dodgy switch on the Variac. Power up, sounds good. Blue lights come on the monitor. Let's see what it's doing. Let's move the camera around. It's gone bleep, that's a nice sign. Flashing cursor I can see. Ah, there we are, yeah. There's no boot device. So that's great, it boots into the BIOS. Well, not BIOS, but it boots up. I haven't got a keyboard attached, I'm sure I could get into the BIOS. Let's see if it boots up with the AGP as well. Switch this all off. Just take this one out. Another good thing with this being a little card, it's easy to get to the release catch, yeah, on the PCIe. When you're working with big cards, it's fiddly, and when you pull them in and out all the time, it's not what you want really. This is another just cheaper, worth nothing AGP card, because all the good ones I either keep for myself or I sell them, yeah. Not even sure what this is, to be quite honest. It seems to be some generic card, but all I'm really interested in is I've got a picture, yeah. So let's have that into the AGP. This doesn't have a DVI connector, so this is the VGA from the same monitor. So what you want in your workshop, yeah, a monitor with you know, DVI, VGA, and HDMI on for just for testing, yeah. Okay, let's get the camera back round again and see what this one's going to do. Microscope out the way. Can we see the picture? I hope we can see the picture. Okay, let's keep that in place. Power on. Again, let's start her up. It's booting. I can see on the post analyzer it's got, I heard the fan slow down like it's got control. Blue lights on the monitor. Anyway. Looks like we have a signal coming up in a moment. Come on. Oh, yeah, bleep. That's good. And what's it going to hopefully tell us the same thing? Come on, give us a picture. Yeah, good. Insert boot media, yeah. So that's good. That's nice. That's a nice motherboard. If you're vaguely interested in retro gaming, that's the really the start of a nice rig, yeah. That's the start of a nice rig for Windows 98 and XP. This motherboard will support, let's just have a quick look onto, I'll show you what it actually supports. Let's go to the screen capture. So, this is a motherboard, Asrock 775Dual-VSTA, yeah. these are all the operating systems, but it does support Windows 98. I know because I've asked on the various retro gaming forums, and they say it definitely does support Windows 98. And a whole range of processors: Celeron D, Core 2 Duos, yeah. So the one I've got at the moment is one of the slow ones. That one, the slowest one. But this will take the E8400, but only partially supported at 2.4 gigahertz. It should run faster. Well, there's 2.66 gigahertz. Oh, this is nice. Intel Core 2 Extreme, yeah. 2.93. Supports Pentium 4s. Pentium D, whole load of them. Pentium Dual Core. Pentium Extreme Edition. I'd have to ask on something like Vogons, which is a very good forum for retro gaming. That's Vogons, which is very old games on new systems. That's what it stands for, yeah. Obviously, you might know the Hitchhiker's Guide to the Galaxy thing about the Vogons anyway. But yeah, I'm looking at this, I can ask, but this Intel Core 2 Extreme seems quite a nice processor. It's almost 3 gigahertz. You can buy these used ones. Let's have a look. Pre-owned, £35, this sort of price. Because I want to keep this board for myself, I will most certainly get one of these processors. I will ask to see if anything's faster, and whatever's the fastest I can get, I'll stick in here. The only thing it doesn't seem to support is Core 2 quads, yeah. Okay, so that's the motherboard. What we'll do is now is we'll just install an operating system on it, and I'll put XP because that supports both the AGP and the PCIe, whereas Windows 98 doesn't support PCIe. So we'll put that on, and then let's have another last look at it, and we'll hopefully see it running some benchmarks or something if you're interested. If you're not interested, well, you can end this video now, and I'll see you on the next one. I hope you are interested, and I'll see you a little bit more with this one soon. Okay, so there we have it. The rig's all set up. We've still got the HD 2400 graphics card in. I say it's a 1.86 gigahertz Core 2 Duo, which is the slowest you can get. I do have a 3 gig Core 2 Duo here, but this motherboard doesn't support that processor, only up to 2.4, so no point really trying to fit that one. But anyway, it is what it is. 2 gig of DDR2. I put a CD-ROM on there just to install Windows XP onto a hard drive, SATA hard drive. So everything's basically ready to go. I've installed 3D Mark 2001. Reason being, XP came out in 2001. Yeah. So I thought it'd be interesting to see, even with a pretty rubbishy GPU on here, what sort of performance we would get, as this machine is really intended for playing Windows 98 and early XP games, really, particularly Windows 98. So let's run the benchmark, and let's see what it actually does. I must find a way actually of basically setting up this recording system so I can actually record directly when I'm outputting from a test rig. You can see in the meantime that she was, well, dipped to 100, but 200 odd frames a second a lot of the time. It's no too shoddy, is it, that? Yeah, as I was saying, so I need to find a way so I can capture from either VGA, DVI or HDMI, so no matter what I'm actually working on, what type of video output as I can capture. Anyway, in the meantime, let's enjoy the benchmark in my rather improvised way of recording it, yeah? Be interesting to know how that would compare to effectively, if you built a high-end system in 2001, what sort of results would you be getting compared to this I have here today? Still going rather nice. I mean, sometimes going well over 200 frames a second. And this is certainly, what you would be using for benchmarking in 2001 when XP was released. Let's switch off the bench light and see if it helps. I was hoping that might cut down a bit the glare. I have powerful lighting above the workbench here with two sort of 1.5 meter fluorescent tubes, high wattage ones. One thing you need for this is lots of light for this sort of work. Certainly I do. Still very respectable, isn't it? I mean, considering the graphics card in particular and the 1.86 gigahertz processor, I think that's quite respectable. I suspect on some of the later tests, I think the nature one's likely to dip. That was always quite a difficult one to run back in the day. In high detail with all the reflections on, still 80, 90, 130, yeah, still getting well. I mean, my intention with this rig, by the way, was going to be, I'm going to move some graphics cards around on my other rig. So I've got an i5820K on an X99 motherboard with quad channel DDR4. That one's going to have the R9 280X in that we fixed a week or so ago, a couple of weeks ago. That'll free up the GTX 960 that's in that one. That's going into my, it's an i7 2600K, I think. It's another overclockable one, about 3 gigahertz. That machine runs Windows 10 and XP. And the GTX 960 is supported by XP. In fact, it's one of the fastest graphic cards you can run in XP. I use that mainly for playing late era XP games and sort of, into sort of the Windows 7 era. I don't tend to play recent games. Moment I'm playing and very much enjoying Borderlands 2. I'm playing all the expansion packs now for it, the DLCs. Yeah, frame rate now, we're 25, 27, 30. I think for what it's running on, yeah, that's quite respectable, for this graphics card. Anyway, so we're moving things around. So out of the Windows 10 and Windows XP rig comes the GTX 750, that's in the now 750 Ti. That's going to go into this rig. So this is going to end up with the Core 2 Extreme, 2.97 gigahertz, which I believe is overclockable. It's going to end up with the GTX 750 Ti in. And it'd be very interesting then to run this exactly same demo again and see what the results are. In the AGP slot, I have a GeForce 4 Ti 4200, which is a very nice graphics card for Windows 98. And I also have a fast HD 7000 series. I can't remember the exact model. That's another AGP card. It's about the third or fourth fastest AGP card that you can actually get, I believe. So that'll go in here as well, and hopefully dual boot with two SSDs. So we can obviously have a very fast Windows 98 and a pretty damn decent machine for earlier XP to mid XP era games. Okay, a couple of minutes left of this, guys. Hope you're still with me. I'm interested to see what the overall score is. I think we can say that this rig's certainly running stable with those new capacitors in there. So that's answered all the questions like, can we use 2.5 volt, can we use 820 ohms? A definite yes and yes in this case. If any of you do know what would be a respectable score for effectively hardware that was available in 2001, please post that. I'd really like to know how this, even how it's set up now, how this compares to what was available then. Just put it into comments. I think we just have a few more tests now. So the only one it struggled on really was Nature, and it was managing about 30 frames per second. I suspect the GTX 750 Ti would make a big difference to that. And still fully supported by it. You know, it has native support for XP. I'm not sure. Yeah, Windows 98 wouldn't run it because it's PCIe. That should be another good thing we can try with this. We can look at basically one of the fastest graphics cards that supports XP, and then in the AGP slot, one of the fastest graphics cards that supports Windows 98 on exactly the same rig with the same processor, the same motherboard. It'd be very, very interesting, I think, to see what the difference in performance is there. Here we go. We have a score. 12,401. 12,401. So I can always look back at this video to look that one up. Okay, guys, that is it then for that. That's basically everything. We have a very nice bit of kit repaired, and I look forward to seeing all you guys on another video. See you soon now.